Welcome. I'm Ichan, an engineer who works on drawing features. In this session, I will show you some exciting new APIs in PencilKit that bring handwriting recognition to your apps, along with improved access to the drawing model that open up interesting use cases. Writing on iPad with Apple Pencil feels as natural as pen on paper. But unlike paper, your handwriting becomes searchable, recognizable, and interactive. PencilKit is the core framework for freehand drawing support on Apple's platforms. It gives you a low-latency canvas with expressive inks, full Apple Pencil support, and access to the underlying data model. iOS 26 introduced PaperKit, which builds on top of PencilKit to power Apple's drawing experience system-wide. All of the new PencilKit APIs covered in this session are also available when working with PaperKit. To learn more about it, check out the Meet PaperKit video from WWDC25 and Unwrap PaperKit video from WWDC26. Apple's platforms have world-class handwriting recognition. You've seen it power features like searching handwriting in Freeform and Notes. One of the most requested capabilities for PencilKit is handwriting recognition. Now, it's available to you in iOS, iPadOS, macOS, and visionOS 27. I'll start with PencilKit's handwriting recognition APIs and show you how to turn handwriting into recognized words. Next, I'll go over new conversion APIs that let you translate between PencilKit stroke paths and standard Bezier paths. Then, I'll cover improvements to the drawing model, including stroke identity and selection access. And finally, I will show new stroke slicing APIs that let you split or extract segments from strokes. I've been working with PencilKit in iOS 27 to build my son an app for learning to write in both Chinese and English. In my app, he can practice writing words in both languages and get feedback on his work. Here, the app has a flashcard showing a word in English. To practice, I will write the Chinese translation. Right now, it's showing heart in English, so I need to write xin in Chinese. Now, the app can use handwriting recognition to check my current work before I finish the whole word. The check button shakes to tell me the answer wasn't right. This time, the app recognized my handwriting as the Chinese word xin, which matched the prompt, and the app confirmed it's correct. Great. That's what handwriting recognition APIs can do in PencilKit. I'll get started with the core of handwriting recognition. PK Stroke Recognizer is a swift actor, so it's thread-safe by design. All methods are asynchronous because recognition takes time. There are three main capabilities that together provide a handwriting recognition experience that is broadly useful for your apps. I will walk through each one. The first capability is recognize text. It returns the single most likely result for what was written. By default, PK Stroke Recognizer uses the device languages to determine how to interpret the handwriting. You can also configure preferred languages explicitly to match your app's language context. You can recognize an entire drawing at once, or pass in a specific subset of stroke IDs. I will swipe over to the open-ended practice view to show recognized text in action. I can write anything I want here, and PencilKit will recognize it. Awesome! Hello, WWDC! As of iOS 27, PK Stroke Recognizer supports 29 languages. The list of languages supported can be accessed using the Supported Languages property on PK Stroke Recognizer. Note that handwriting recognition in Simulator only supports languages that use Latin characters. Handwriting recognition in PencilKit runs entirely on device. The recognition model is offline and included with the operating system. Handwriting recognition is fast and works on all devices supported by iOS 27. The next API is indexable content. It provides a single string representing the contents of the entire drawing. This is particularly useful for features like Spotlight search. When multiple languages are active, indexable content may contain results in more than one of those languages. When handwriting is ambiguous, you want all possible interpretations in your index, so users can find their contents regardless of what they search for. Is that 1 or lowercase l? Is that 1 or LOL? Where recognized text gives you one best answer. Indexable content gives you all the candidates concatenated together. If you are persisting indexable content to disk, keep in mind that recognition results can improve over time as the underlying models are updated. PK-stroke recognizer exposes a recognizer version property. Store this alongside your indexed content. And when loaded back, compare against the current version to decide whether to reindex. Additionally, consider throttling your calls to PK-stroke recognizer. Updating the results on every stroke may use more power, so you need to provide your indexing feature. The third API is for searching text. Given a target string, it returns an array of search results, indicating where that word likely appears in the drawing, considering all the candidates. This is what powers interactive search, where a highlight appears around matching strokes. Search also pairs naturally with UI find interaction. The system find and replace experience. By implementing UI find interaction delegate and driving it with search under the hood, you get the system search UI complete with result navigation and highlighting directly in your drawing canvas. Back in the flashcards, I've made a change to show how the search function powers flashcard matching. I've added a visualization of the bounds returned in search results. Now, there's a box showing where the search matched. These capabilities also make handwritten content more accessible. You can connect VoiceOver to speak handwriting aloud, making handwriting accessible to people who rely on screen readers. And search lets assistive features locate and navigate to specific words within a drawing. Together, they help bridge the gap in accessibility between handwritten and typed text. Next, path conversion. Path conversion is a powerful set of APIs that help you to bring PencilKit to your app. PencilKit represents stroke paths as cubic uniform B-splines. For more information on how PencilKit stores paths, check out the Inspect, Modify, and Construct PencilKit drawing video from WWDC26. B-splines are a great representation for drawing, but are less common than Bezier paths. In iOS 27, PK stroke paths support conversion between the two. When converting a path, PencilKit handles the geometry. Bezier paths don't carry PencilKit properties like size, opacity, or force, so you need to provide those for each control point. When starting from PK stroke paths, converting to and back from a Bezier path will result in the same control point locations, allowing for storing PencilKit strokes in a Bezier-based format, and reconstructing without any loss of fidelity. If your app has its own canvas with strokes stored as Bezier paths, you can now convert those to PK stroke paths, build a PK drawing, and feed it into PK stroke recognizer. This makes handwriting recognition compatible with any canvas, not just PK canvas view. Beyond expanding where PencilKit can be used, iOS 27 introduced key additions that enable deeper access to the model. This flexibility supports more custom use cases in your apps. PK stroke and PK stroke paths both gain conformance to the identifiable protocol. It is a stable UID, so you can track a stroke cross transforms, edits, and undo operations. With a stable identity in place, you can now control the selection state on PK Canvas View. There's also a new dedicated method, Canvas View Selection Did Change, that fires whenever the user's selection changes. When certain inks are drawn together quickly, PencilKit composites those strokes together as if the inks were still wet, by using an equal render group ID. In iOS 27, it is now controllable. The last set of new APIs gives you the ability to slice through strokes in two different ways: programmatic erasing and substroke extraction. If you have worked with PencilKit's data model, you may already be familiar with the stroke mask. PencilKit represents partial erasure using a mask. When the pixel eraser removes part of a stroke, the remaining visible portions are defined by a mask. Starting in iOS 27, you can apply the same operation programmatically. You provide a PK stroke path as the eraser. It cuts through the drawing, slicing a single stroke into multiple independent strokes with their own mask, just as if the user had used the eraser tool on the canvas. One thing to keep in mind, slicing can be expensive on complex drawings. If your drawing has a large number of strokes, be mindful of performance and consider erasing on a background thread, rather than blocking your UI. Where erasing visually cut strokes, substroke extraction lets you efficiently obtain a section as a new stroke or pass. Starting in iOS 27, both PK stroke and PK stroke paths support subscript access with parametric ranges anywhere along the path. This gives you process control over exactly where a slice begins and ends. PencilKit inks have features like pencil texture particles that are positioned relative to the full stroke. When taking substrokes, PencilKit maintains the consistency of those particles. For Chinese characters, the order that you write the strokes is important. To check that order is correct, I built a feature using substrokes to replay how I wrote the word. PencilKit implements rendering in metal with optimizations that make my animation smooth. To take full advantage of these powerful APIs, adopt PK Stroke Recognizer and bring handwriting recognition to your app. Try PencilKit in new places to convert your existing Bezier paths into PK stroke paths and take advantage of handwriting recognition, even without PK Canvas View. Dive deep into PencilKit's model to track strokes with stable identity, respond to selection changes, and build a new level of custom experiences. Finally, take advantage of stroke slicing, cut through drawings with programmatic erasing, and build smooth animations with substrokes. Each of these APIs are simple to integrate. Together, they unlock features in your apps that were not possible before. The sample code for the demo is available in the resources for this video. Handwriting becomes recognized, searchable, and interactive everywhere in your app. That's PencilKit in iOS 27. Thanks for watching.